When it's October 20th. All right, October 20th. Hold a second. I need to do one more thing before I start. Wait, hold a second. Where is my... Okay, here it is. I'm charging my bike light. So I need to keep it charged. Well, I saw my dad off this morning. He go back home. So yeah, I don't feel any real sad, but it is interesting experience living with him for I think a little bit over a month, 5 weeks, 5 or 6 weeks. I have not lived with him since, gosh, I mean I was in boarding school in high school, so back then it was only 2 days a week at home. Oh, but we have holidays, summer break, winter break, and that was a long time at home. So yeah, I still consider living with him back then. But starting from college, I was away. Like, uh, so since college until now, that's many many years, and I haven't lived with my father or my mother for an extended period of time. And now living together for the past month and a half. Yeah, I think it's a month and a half. It was quite interesting. It was quite interesting to feel his presence, and people change. Well, I honestly I think probably I change more than he changed. But it's interesting that the things he says, and things he says, things he do, his opinions, my view of life. We are in conflict in quite a lot of fields. I don't like a lot of ways that he treats life, and nor does he like the way I deal with life. But at the end of the day, it's still my father, right? There's still love in there. It's interesting. It's an interesting thing to experience. All right. Anyway, let's dig into this. All right. What do we have today? Split a string into maximum number of unique substrings. Oh, that is interesting. Given a string S, return the maximum number of unique substrings that the given string can be split into. You can split S into any list of non-empty substrings where the concatenation of the substring forms the original string. However, you must split the substring such that all of them are unique. Hold a second. What are we doing here? Maximum number of unique substrings so after we split, they must be able to put together into the original string, right? Any list of non-empty substring where the concatenation would need to form there. So this one, A, B, C, 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 okay. This one is not allowed. All right, 16, 2 to the n. Just need to figure out a good scheme to do this. What do you think? So A, B, C, 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 right? So again, at each position, we can do something like, I don't know, like backtracking kind of thing. So I mean, we can say I'll take A out, and then I'll find the remaining. Right, we'll break down the remaining. But then we have A, so we need to pass a set into it so that we don't split something that's already there, right? Okay, so if we have a helper function, we need the string, we need the index, and we need a set that the current already there, right? And for each position, for each index, I can choose to make it into itself, or I can group it with the remaining, Yeah, I mean for A, like I can do A by itself, I can do AB, I can do ABA, I can do ABAB, like I can do anything. And then we go to the next one, so I can do B, right, by itself, or BC or BCC. Yeah, we can just do all that. And since we have a set, I don't think we can put a DP onto it. Okay. However, we are able to. Are we able to? Because we want to find a maximum, right? So yes, we are able to terminate it, right? Because we will go through something, go to the end, and we'll set up the current max. Okay, we'll set the current max. And if along the way, it's not likely to get to the max, then we can just say, yeah, we don't have to do this anymore. Interesting. Let's give this a shot. I do think it is going to be 2 to the end. That should be sufficient. Right? That should be sufficient. Okay, so what we need is, how do I define? When we say int res equal to 0, okay, private. Do we return anything? Int. We don't return anything. We don't have to return anything. So we say helper. All right. So we need the string. We need the index, and we need a set. I guess it's fine. Scene. Okay. If you want to do it that way. Okie dokie. All right. So if index is equal to s dot length, right? So we done everything. Then we'll just say, actually we probably shouldn't do this. Res equal to math dot maximum res, and this dot scene dot size, right? That's it. Otherwise, we can just keep going, right? Or keep going to the end, and each time we say we'll do this, we do this, we do this, then we need to call. Darn, we'll call substring. Let's just call substring. I mean, I don't know. So we can say string current for int I equal to, from index I smaller than s dot length I plus plus. Okay, so from index, so we can say string current. Well, actually we can also, we actually can, we can do a check, which means the remaining. So we can say if this dot scene, right, dot size is a current one plus 1, because I'm gonna do that, and plus from so I from index to I, and then from I plus 1 to the end, how much there is. So this one minus, so like if I have 3 and I have 0, right? So the index is at I is at 0, then I plus 1 is 1, so 3 minus 1 is 2. Yeah, so minus I plus 1, right? So this, now I have a plus 1, I have minus 1, so basically we say if this size minus I is the total number, maximum number of substring that we can create. If this is smaller or equal to this dot res, then we just break it. We don't have to keep going. Otherwise, we'll say s dot substring okay, so beginning to end. So beginning is going to be index, end is going to be I plus 1. Okay, so we'll have the substring. If this dot scene dot contains current, right? I contain the substring, then we'll continue. We cannot do it anymore, right? Otherwise, if it does not contain, right? If it does not contain, ooh, hold a second. I probably should do it this way. If it does not contain, right? If it does not contain, then we can do it. So I do it by this dot scene dot add current, right? It does not contain, we add the current, and we call helper s I plus 1. As we up to I will handle this, and then we pass the next one into it, and then it will just do it. And then once it's done, this dot scene dot remove current. So this is backtrack, right? And if it contains, we just skip it, and then we'll do this. Yeah. Okie dokie. So once this is done, we will and we'll call this function. We'll call helper s, and we'll start with 0, and we'll return this star res. Let's take a look. Take a look, see if this is a correcto mondo. Looks about right. I'm gonna submit it, and 1593, right? Recursion with O n times 2 to the n. Backtrack, don't call it recursion. Backtrack. Basically, we try all combinations of splitting the string and return the max count of substrings in among them. Yeah. I'm gonna throw some curveballs at it. For example, we do this. For example, we do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, looks about right. Let's submit it. Yep. I think this is the right method, most likely. Okay, so what do we have? What is this? Okay. Yes. Yes. Oh wait, what is this? This is really good. Managing elements while continuously finding maximum or minimum values. Yeah, monotonic stack is a very good technique, but I don't think I'm very good at it so far. Graph tree, DFS, BFS, linked list. Oh, you have this thing. Oh wow. Yeah, DP doesn't work is because you have this scene. Because this one cannot contribute. You cannot summarize this into a state. So DP does not work. All subsets, yes. Backtracking, yeah, this is what we do. Nice, we have the same name. Oh, you pass it to it. Ah, that's fine. Oh wait, this one just set it. I like to set it on the outside so I can change. But yeah, we know what this is. If it doesn't contain, right, and then we do this, we do the max count, and backtracking. Yeah, n times exactly. I at least got this one right this time. Backtracking with pruning. What type of pruning are you talking about? I have some pruning. I have this is my pruning. What else pruning are you talking about? Oh my god. Sheen max count. Yep, pruning. I have this pruning as well. If the current count plus remaining characters can exceed maximum return. Exactly. It's exactly what I was talking about. So I have the pruning. Oh. Great. I really hope after reading this, people can get aha moment. I mean, it'll take a. It took me a long time to get to like understand this. Not really understand this, to internalize this, right? And I would say I'm fully internalized. Like this one, yes, I internalized this binary such, right? Two pointers, not so much, but I think I have a feeling for it. DP definitely. I've done a lot of DP problems, but the really tough ones is really tough. The way that I identify whether a problem can be DP or not is to see if I can find a state. Because DP basically you're managing states, right? You're going through all possible states. So if I can find a state for the problem that I can describe all possible states, right? It's usually if it's an array, you can have index or two index, right? It's kind of two-way dynamic programming. Or sometimes you can use a bit mask, use that as a representation of the state. So if you can find a state, then yes, you'll go with DP. And again, in this problem, you cannot use DP because you need to keep track of what you have put, right? What substrings you already put, and this can only be done with a hash set. And if it's a set, yeah, you really can't turn that into a state. Now here is what gets tricky, because sometimes sometimes a set can be turned into a state. That's what I was talking about, the bit mask. You can use a bit mask to represent a state that usually you have to use a set. But in our case, yeah, it doesn't really work. So because you cannot form a good state for this problem, DP is not going to work. Backtrack, exactly. If you see the n is small, like n in this problem is 16. So you see n is 16, that's immediately 2 to the n, right? And what is 2 to the n? 2 to the n is listing all possible ways. Then backtracking is one of those ways. I mean, in fact, this one is, it feels also similar, the thought process, similar to knapsack. Because you say every one, I'll take it, or I'll take it as itself, or I take it as 2, I'll take it as 3. I mean, knapsack is for each item, you either take it or you don't take it, right? So you kind of have this idea. Backtracking for this. Try is very straightforward. Prefix matching, almost 100% of the time you use try, because it significantly reduces the time complexity of dealing with it. However, you do have to write try, so you need to write try a few times to get familiar with it. This is just common sense. Monotonic stack. I think this is probably one of the hardest, at least for me, to identify that the problem needs to be monotonic stack. I still don't have a good intuition, but we know like if you need, okay, like a typical monotonic stack is to find the amount of water that can be held like by towers. And I forgot that problem is you have a different heights of tower. Some are tall, some are low, and then the low ones can form a pond, like a container, and they can hold the rainwater. Yeah, they can hold rainwater. Like that is monotonic stack, because you are able to sort, right? You're sorting it while you're also gaining information of everything that's in between. That's that kind of thing. The skyline. I remember there's a problem about skyline that requires monotonic array, and there are many things require monotonic array, and it's always very smart to use monotonic. Now, what hasn't been put in here, you also have a stack. We had some problems, I think yesterday, evaluating a Boolean, right? Boolean expression. So evaluating an expression, pairing parentheses and all those, it's most likely stack. You just have to be a little bit smart of how you handle the stack. And it also has like a kind of way to do with it. Now graph, it's way more complicated than what just these three showing. Okay, so you have the BFS, DFS for sure, and you have Dijkstra, right? That's also like a staple you need to know. And honestly, I already forgot, but there's Warshaw. Oh my God, I forgot the name. There's Bellman-Ford. There's the Warshaw algorithm, and a bunch of others, right? You use those to find the minimum weights between any two pairs, something like that, right? So you need to know those, and union find, extremely useful, right? Union find, extremely useful for graph and trees. Topological sort, it's another big one that can be very helpful. Sometimes you don't have any idea. That one is BFS, shortest path, exactly, fewer steps. But like I said, you have Dijkstra, right? We have Dijkstra when the shortest path, you have weights on the path, right? So these are what the graphs, but graph is a very, very wide and a big topic, and that's also one of my weakest, right? Linked list is, in my opinion, one of the easier ones. I mean, it's not, again, we have this this comparison between a complex problem and a complicated problem, right? And to me, I think linked list is a complex one. It's not complicated, it's complex. So you have to be very careful when you write the algorithm, but the overall mental image of linked list is very straightforward, because there's only one way to do it, right? You traverse forward, you traverse back, you have the tortoise and hare algorithm to detect loop, and you also need similar things to detect where the loop starts. Like these are the things for linked list, but other than that, I just be careful. Dummy nodes, very important for linked list. They help you simplify your algorithm. Yeah, so there are definitely patterns. That's why LLM can solve these toy questions, because there are patterns, right? And then machine learning is very good at identifying patterns. So it's definitely it's a trainable, right? It's a trainable skill. But still, even for me, after doing it for so many years, it's still a struggle from time to time, right? Yeah. Yeah, and the reason I'm doing this today is because I kind of don't want to go into this, because I was trying something yesterday, and then no, 2 days ago, and it was not working very well, and I kind of I just don't want to do it today, so I'm just keep talking, and then we'll use up the time. So we'll do it, yeah, some other day. All right, that will be it for today. I'll see you guys tomorrow. Adios. Gotta go train.